Lesson 3-2, Linear Equations. Linear just means that it forms a straight line. Line is what linear means. We have several characteristics of linear equations. They can be written in the form y equal mx plus b. Variables have exponents of 1, which you won't see the 1 labels. It's usually it's invisible. Variables are not in the same term, such as x times y. Those can't be together in a linear equation. Variables can't be in the denominator. An exponent can't be a variable. You could have a number raised to an exponent that's a number, but it can't be a number raised to x. There's no absolute value symbol or root symbol for the variable. So you'll write this list down and use it for reference. It may seem kind of lengthy, but most of these, as you get used to seeing them, you'll recognize automatically that something doesn't look right if it's not linear. Example 1, is it linear? And use your list for reference. A part, y equal 3x minus 4. Notice that it is written in y equal mx plus b. So yes, it is linear. B part, y equal 4 over x. This one is not linear. Notice that it's dividing by x. It's dividing by a variable, so it's not a linear equation. C part, 3x minus y equal 2. Notice that this appears to be one that we've worked with before, this type of equation. It's a standard form equation, and it can be rearranged into y equal mx plus b. Our first step was to get rid of that positive 3x by subtracting 3x from both sides. And then we divide both sides by negative 1 to get y equal 3x minus 2. So yes, it is in the form of y equal mx plus b, so it is linear. D part, x equals 7. Well, this can actually be graphed as a line. If we draw a little coordinate plane, and you don't have to draw that, but we would have where x is 7, which would fall about here, and it's just going to be a vertical line. So, is this vertical line linear? Yes, it is a line, so it is linear. Y equal 4x squared minus 1. No, it's not linear. The problem is it's got a variable with an exponent other than 1. F part, we have y equal the absolute value of x. No, it's not linear. We're not finding that, we can't find the absolute value of x in a linear equation. Part G, xy equal 8. No, this is not linear because we have two variables in the same term. Remember, term can be variables or numbers that are multiplied together. In this case, we have two variables multiplied together, so no, it is not linear. H, we have y equal 3 to the x power. No, this is not linear because we have an exponent that is a variable. I part, we have y equal negative 10. So remember that we can graph this and it will be a line. You don't have to graph this, but we go to where y has a value of negative 10 here. And everywhere that y has a value of negative 10 will be across this horizontal line. So it does form a line, so yes, it is linear. J part, we have y equal 4/5 x. It almost looks like it fits y equal mx plus b. If you don't see a number behind the x, it could be just adding an invisible 0, which if you add 0, we're not going to change anything. So really, y equal 4/5 x plus 0 is in y equal mx plus b. So yes, this is linear. And you can leave it as y equal 4/5 x. Example 2. Is the rate of change constant or variable, and is it linear? Well, rate of change is just another phrase for slope. And if it's asking if the slope is constant, it means that the slope is the same no matter where you find it on a line or you could be looking at slope on a curve. But if it's on a line, it's going to be constant. It'll have the same value and it will just be a line. And if it's a slope that changes, it varies, then it's not a line. So that will answer the next question, is it linear? If it's constant, then yes, it's linear. So this is part A. We have a table of values. Notice there's 4 ordered pairs here, and we want to know if the slope or rate of change is the same between each of these ordered pairs. Now, we know we could use slope formula over and over and over here, but I'm going to show you a shortcut, and it's finding slope. Remember that slope m is the change of your y's over the change of your x's. So if you put your ordered pairs into a table form, then we can quickly find this by counting. Look at our y's from -3 to 0. -3 goes up 3 to get to 0. So the change in the y here was 3, positive 3, when our x's changed by going from -1 to 0, which means it counted up 1. So between these two ordered pairs, -1, 3, and 0, 0, the slope is positive 3. We can do that for each one of these. We'll find from 0 to 3, it goes up 3. From 0 to 1, the x value, it goes up 1. Make sure you always say the change of y's over the change of x's, because that's what slope is the rise over run. But we get 3 again. For our last one, we have the change of our y's goes up 3. The change of our x's goes up 1. 3 over 1 is 3 again. So to answer the question, is the rate of change constant? That's the same. Yes, it is constant. Is it linear? Yes, it's linear. We know that because the rate of change is the same. B part, we have another table of values, and we're going to see whether our slope, called rate of change, is constant or variable, and then whether this is linear or not. So remember, we can find slope by using the change of the y's over the change of your x's from a table. And so the change of the y's, from 4 to 0, it goes down 4. From -2 to 0, it goes up 2. So -4 divided by +2 is a -2. From 0 to 4, it goes up 4. And 0 to 2, it goes up 2. So from 4 divided by 2 is +2. Notice the signs are different there. From 4 to 49, it goes up 45. From 2 to 7, it goes up 5. 45 divided by 5 is 9. What you'll notice is that your rates of change are all different. Now, you could have had different numbers that you plugged into your fractions, and they might have simplified to be the same answers, but they didn't here. They're all different. So if they're all different, or even if 2 were different and 2 were the same, for example, if they're not all the same, then this is a variable rate of change. The slope varies. Is it linear? No, it's not linear. This would end up looking like a curve if you were to graph it. The line.